Good morning to everyone present here. I extend a hearty welcome to all for the keynote session titled The Role of Engineering Education for Sustainable Development by Professor CHITHIRAI SELVAN at IACEST 2023. I request Mrs. Rupa to introduce the keynote speaker to the gathering.
Very good morning to one and all present here. Professor CHITHIRAI SELVAN has extensive experience in teaching engineering students and has worked in academia for over 23 years. He has published more than 150 research articles in journals and conferences. He has been invited and honored as keynote speaker, session chair, resource person, and technical committee member of various conferences held in UAE, India, Thailand, Malaysia, Germany, Italy, Australia, Qatar, and the UK. His research interests are in the areas of machine design, optimization techniques, manufacturing practices, renewable energy, and engineering sustainable development. He is a well-known researcher in the field of abrasive water jet cutting technology and has evaluated several PhD theses in mechanical engineering from various universities. He is the approved supervisor of many universities including Curtin University, Australia, to guide PhD scholars and has produced many PhDs. He is a member of many professional societies including SAE, ASHRAE, IMEC-E, ASME, EI, ASQ, and ISTE. He is also a senior fellow of Higher Education Academy, SFHEA UK. Professor Pon has received several prestigious awards in UAE including following: Teaching Excellence Award from Manipal University, Dubai in 2014, Dubai Award for Sustainable Transport from Road Transport Authority RTA, Government of Dubai in 2017, Dr. Kalam's International Excellence Award for Education from Dr. APJ Abdul Kalam Lovers Foundation UAE in 2017, Distinguished Conversation Project Award from Dubai Electricity and Water Authority DEWA Government of Dubai in 2018, Alim Sustainability Researcher Award from Alim Research and Development Center Sharjah in 2018, Sustainability Ambassador Award from Road Transport Authority RTA Government of Dubai in 2019, Research Excellence Award from Curtin University Dubai in 2020, TAG Founders Award Academic of Year 2021 from Transnational Academic Group TAG Dubai in 2021, Curtin Global Award 2022 from Curtin Global Curtin University, Assumin Award for Education Dubai from News 7 Tamil News Channel in 2023. Prior to joining Curtin University Dubai in July 2018, he served for 10 years in the UAE with Manipal University Dubai and Amity University Dubai. We all welcome you for this event, sir. Thank you so much.
I come from Curtin University Dubai. Curtin University Dubai. Can you hear me?
No, sir, mic is not working.
Curtin University Dubai is a can come and see. Please. Curtin University Dubai is a branch campus of Curtin University in Australia. Curtin Australia is top 1% universities in the world, number 2 in the world for minerals and mining engineering, top 50 for chemical engineering, top 100 for civil and construction engineering. Almost all our engineering programs are within top 10, 100 or top 50 in the world. The largest university in Western Australia. We have global campuses in Malaysia, Singapore, Mauritius, Dubai, now in Sri Lanka. We have 6 global campuses. All the places we offer the same degree what is offered in Australia. We follow the same structure curriculum. So Dubai campus is a branch campus. Even in Dubai also, we are the highest Western university in the UAE. As per Knowledge and Human Development Authority last year survey, we are a 5-star university in Dubai. I would like to thank you all for joining this meeting. I'm going to talk about the role of engineering education for sustainable development. Some of the global perspectives on climate change we'll discuss. Then the definition of sustainable development and sustainability. Some of the important resources that we should consider: water resources, energy resources, hydrocarbon resources, materials, sand, cotton, soil. Then solution: linear economy to circular economy, industrial symbiosis system, IPAD, which is a very well known equation for engineering. We'll discuss about these. You might have seen these kind of articles in the recent times. The Earth has endured 14 straight months of record-breaking heat, 54 degrees Celsius in Kuwait, disaster. These are only samples, but it is happening in many places unnoticed. The temperature is increasing. Because of the high temperature, bushfire, wildfire, all these are happening. Last year on 6th August, same day, Turkey marks 10th day of forest fire. On the same day, homes destroyed as forest fires ravaged in Greek island. Over 100,000 people to evacuate in California on the same day. Deadly British Columbia heat wave left 100 dead. Bushfire in Australia. All these happen at the same time. Drought is happening frequently. Few samples only I have given. This is not the only ones. There are many other things happen everywhere. Extreme drought in Kazakhstan, steppes, horse deaths. It is not only affecting human beings, microorganisms in the soil, insects, animals, plants, trees, everything getting affected. Lake in New South Wales was dry during the height of the drought. Cracks in drying lake in Nevada in the US. So average temperature is rising by 0.3 degrees Celsius every decade. Some 42% of the California's population is now under drought emergency. Flood is happening. This is also because of the high temperature. How it is? When more temperature, more seawater will become vapor. Not only seawater, water on the land also will become vapor. Therefore, more cloud formation, more rain. So indirectly, seawater comes to the land. This is because of the climate change, high temperature. Just watch this. Because of the high temperature, the glaciers are melting. Greenland, in the Antarctica, in many parts of even in India, Himalayas, Uttarakhand, Uttar Pradesh, glaciers are melting. After melting, the water goes to the sea. So the sea level is rising. We are losing our land because of the sea level rise. If you see, by the end of this century, the global mean sea level is likely to rise at least 0.3 meters. Above 2000 levels, even if a relatively low pathway. If it is extreme pathway, then it is 2.5 meters above the sea level rise. That means we are going to lose land on the land. The world's fastest sinking city due to sea level rise is North Jakarta, which is the capital city of Indonesia. Because of that, they are going to move this capital city from Jakarta to some other location. Even I come from Tamil Nadu, Chennai, Thoothukudi, they are all on the list. See, because of the sea level rise, many parts of the world is going to lose land. Greenland ice sheet is losing more ice than it gains by snowfall. Melting ice sheets in Greenland and Antarctica contributed 14 millimeter sea level rise between 2003 and 2019. I'll not waste time here. Let me go to the next one because I have only 40 minutes time. I have some videos. If I have time later, I will play these videos. Otherwise, I can share this presentation. The number of average number of hot days are increasing every year. Average number of cold days are decreasing every year. All these, every slides I have put a reference. I'm not just like that talking. If you see the temperature, the current temperature, global mean temperature is 1.19 degrees Celsius above the pre-industrial level. That means what? our body temperature, we say 36 degrees Celsius or 37 degrees Celsius. If 1.1 degree or 1.9 degrees Celsius is more, we say we got fever, body got fever. When we have fever, we cannot work properly, we cannot eat properly, we cannot do anything. That is what has happened to the planet. The planet temperature has increased 1.19 degrees Celsius above the pre-industrial level. It is not, the planet is not only for human beings. This planet is not only for human beings. Animals, plants, trees, insects, microorganisms in the soil, all are important. We may withstand 1.1 degrees Celsius. What about the microorganism in the soil? If we take handful of soil, around 5 to 6 billion microorganisms are there in the soil. Even 0.1 degree Celsius increase in the temperature will make a big difference. Areas experiencing record-breaking heat from 2015 to 2022. Only last year I put the important climate change events. Forest fire in America, 1.2 lakhs acres of areas affected. Record-breaking heat rainfall in Pakistan, 1,700 people died, 7.9 million people displaced, 33 million people affected. Iran recorded the hottest temperature, 53 degrees Celsius last year. Europe used to have very cold climate, but last year the temperature went up to 47 degrees Celsius. Switzerland, the melting of ice glaciers, 6% of the glacier ice volume was lost in 2021 and 2022. Drought in East Africa, Ethiopia, Kenya, Somalia, these people got affected. India witnessed extreme weather events, drought as well as flood. Rise in global sea level rise was high in 2022 compared to any other years. California in 2022, June 2022, drought. In the same location, January 2023. In 6 months' time, there is a snowstorm. Extreme weather events happen in 6 to 7 months' time. What are the other indicators of global warming? Glaciers are reducing, snow cover is reducing, tree lines shifting poleward and upward, spring comes earlier, species migrating poleward and upward, air temperature near surface is increasing, sea temperature, surface temperature is increasing, sea level is rising, ice content in the sea is decreasing, ice sheet is decreasing, ocean heat content is increasing, humidity is increasing, temperature over ocean increasing. Each and every indicator there are impacts. For example, ocean heat content is increasing because of that the fishes and other coral reefs are destroyed. This is an example. I am the witness. Vedandangal Bird Sanctuary in Tamil Nadu. This is the oldest birds sanctuary. More than 40,000 birds used to come to this place during the migratory season. This year, in January, last January, when they came, there was no water. Most of the birds died. So, we are losing the natural ecosystem. Climate change might affect flight travel also. There are many things. I don't want to play these videos here, but okay, maybe you can look at this. This is from the World Economic Forum. Okay, I'll play this video.
Wednesday night, we will give tens of millions of Americans facing another round of air quality alerts due to heavy smoke from those Canadian wildfires. Residents across 17 states from Iowa to New York and as far south as the Carolinas.
Just last week, in the US.
Underlying medical conditions. Look at these pictures. I mean, some big cities.
Okay, I can give these videos later. Let me go to the next. This is from the United Nations Office for Disaster Risk Reduction. So why this heat is happening? What is the reason? Because of the greenhouse gases. We say chlorofluorocarbon, methane, ozone, nitrous oxide, carbon dioxide. Compared to all these greenhouse gases, 50 to 60% is carbon dioxide. Therefore, we are always calculating greenhouse gases in terms of carbon dioxide equivalent. But nitrous oxide, for example, is 265 times more powerful, more dangerous greenhouse gas. If 1 kg of nitrous oxide is released, it is because of the application of chemical fertilizers. 1 kg, if it is released, it is equivalent to 265 kg of carbon dioxide. But the amount of nitrous oxide released to the atmosphere is less when compared to carbon dioxide. Methane is 25 times roughly more dangerous than carbon dioxide. This number will vary based on the cloud chemistry and cloud atmosphere. Every year this number will vary. These gases will stay in the atmosphere for 50 to 200 years. When the energy from sun, heat energy from sun, when they travel from sun to earth, the intensity is more, the wavelength is very short, they can pass through this layer and then come to the earth's surface. Some energy reflected back to space. When they go back to space, the energy intensity is low as well as the wavelength is very high. Therefore, they cannot pass through this layer. The heat is getting trapped. That is the reason we get more temperature. To reduce the temperature, there are a lot of United Nations conference of the parties happening. More than 27 last November last year. COP27 happened in Egypt. United Nations conference of the parties. COP28 is happening in Dubai this year. COP28. So far 27 meetings happened. More than 180 nations participated last year. This year also 194 nations are participating. So far 27 meetings happened, but the climate change is not stopping. The carbon dioxide emission is not stopping. It is only accelerating. The crux of the matter is carbon emission. Solution is cut down carbon dioxide emission, but in spite of all these actions, carbon dioxide emission is increasing only. According to IPCC, the Intergovernmental Panel on Climate Change, children born today, when they reach 30 years of age, they will be living between the disasters. Disasters means wildfire, bushfire, drought, flood, cyclone, earthquake. These kind of disasters will be very frequent and the intensity also will be more. If this projection becomes reality, nobody can live well. That is not the place we want to live. That is, some of us may not be here. Some of us may not be here. But that is not the place we want to leave our children and go. We cannot ignore these reports. More than 180 nations, more than 1,000 scientists participate in preparing these reports. Therefore, we cannot ignore these reports. Out of 100 climate experts, 97 think humans are changing the global temperature. It is all because of human activities. Since everybody is using energy, water, materials, everybody is responsible for climate change. If we drink water, here maybe, I don't know water where it comes. In Dubai, water comes from the desalination plant, many parts of the world. Desalination is a very energy intensive process. You have to remove salt, add minerals into it, pumping water into different locations. All these stages, you need energy, electricity. That energy comes from the fossil fuel, from the carbon dioxide emission. Therefore, carbon dioxide is emitted. We use different kinds of materials, mobile phones, laptop, washing machine, fridges, table, cars, private jets, airplanes. All these materials, where are they coming from? From the mother nature. Extracting, mining, refining, processing, storing, assembling, manufacturing, transporting, using, even recycling. We need energy. That energy comes from the fossil fuel. Petrol, diesel, coal. These are hydrocarbon resources. So when you burn these resources, when you produce electricity, carbon dioxide is emitted. So everything, whatever activity we do, everything is related to carbon dioxide emission. We are connected online, we are in the conference. If we consume 1 unit of electricity, 1 kilowatt hour, how many of your electrical engineers are there? Electrical. If we consume 1 unit of electricity, 1 kg of carbon dioxide approximately is released to the atmosphere. If you just iron your shirt for 5 minutes, around 200 grams of carbon dioxide is released to the atmosphere. We all use transport. If you use 1 liter of petrol or diesel, approximately 3 kg of carbon dioxide is released to the atmosphere. We all use LPG gas. If you use 1 kg of LPG gas, around 4 kg of carbon dioxide is released to the atmosphere. So whatever we do is, carbon dioxide is being emitted. An average Indian is releasing 200 kg of carbon dioxide every month. From the entire planet, 1.3 million kg of carbon dioxide approximately is going to the atmosphere. We don't even see that. All that goes to the atmosphere and stays there for about 50 to 200 years. That atmosphere, we have finite amount of space. We cannot extend and we cannot make a big atmosphere. And that atmosphere is common to our entire nations. We have, for political reasons, economic reasons, we have boundaries and borders. But for the atmosphere, there is no boundary and border. Therefore, a damage conducted in one part of the planet has global consequences. Climate change cannot be addressed by only one country, one college, or one group of people. The message should go to everybody. We need to create that awareness. So whether American or Indian, whether rich or poor, everybody is responsible for climate change. Everybody should participate in climate change corrections. Population is increasing. Last year, November 15th, 8 o'clock in the morning, UTC time, the 8th billionth baby born on this planet. We are officially more than 8 billion people. 100 years before, the population was 1.9 billion people. So that means the four times increase in the population in 100 years' time. Is there any increase in the size of the planet? No, we have only one planet. We have a limited amount of resources. Many parts of the world, we are already running out of energy, petrol, diesel, water, sand, soil, land, and many other critical resources. We are all nice people, but we are too many people. Not only population increase, the consumption pattern also increased. Currently, we are consuming 1.7 planets equivalent amount of resources. Your grandfather, grandmother, did they use mobile phone, laptop? But we use a lot of sophisticated equipment. When I was a child, till 8th standard, I did not have electricity at home. We use kerosene lamp. Have you seen this? Maybe your father might have experienced. So we have a lot of sophisticated equipment. 2-3 mobile phones, 2-3 laptops, cars, 2-wheelers, 4-wheelers, so many equipments are attached to that. All these materials, where are they coming from? Extracting, mining, processing, again, all these stages, energy required, that energy comes from the fossil fuel. 1.7 planets equivalent amount of resource means we are consuming, overconsumption is happening, 70% extra we are consuming. That's supposed to go to our future generation. Indirectly, we are living on a stolen resources. It's supposed to go to our future generations. If we continue doing like this, by 2050, there is a research evidence, just like that I'm not talking. 3 planets equivalent amount of resources required. Even if we go to Mars, it is not possible. Yeah, of course, Mars and other planets, we cannot live. You know, the temperature is more there. Only the planet, Mother Nature, is the only place where we can live. So there should be a rapid reduction in our consumption pattern as well as the population. We need to bring back to 1 planet equivalent amount of resources. This is what engineering education is required here. So what is this sustainable development? It is a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. We need to enhance our comfort and conveniences, but at the same time without compromising the ability of future generations to meet their own limits. Sustainability is the goal. That is the end point of the process, sustainable development. So I don't want to talk about this. I can give you later these videos. What is engineers' role in sustainable development? Soon after the 1992 Rio de Janeiro summit, that was the first climate change conference in Brazil conducted. 2,500 issues found in Agenda 21. 1,700 seem to have engineering or technical implications. At least 241 appear to have major engineering implications, because engineers are the ones who are involved in all this manufacturing, mining, processing, extracting, refining, assembling, storing, transporting, recycling, all these activities, they are involved. Therefore, they are the ones who can play more in sustainable development. They are the ones implement government policies into action. So, engineers' role are very important in sustainable development. Now let us discuss some of the important resources. Water resource. Water, imagine if water is not there for one day. Then water is the only God. Water is the life-making material. Water is the only substance available in all the 3 states. Liquid water, solid ice, steam. I teach manufacturing engineering, I do research in manufacturing. I can tell you, to manufacture any product, we need water, directly or indirectly. To manufacture a sheet of paper, we need at least 6 to 10 liters of water. To produce electricity, 1 unit of electricity, 300 to 600 liters of water required. To produce a shirt, 3,000 liters of water required approximately. To produce a set of shoes, around 10,000 liters of water required. To produce a car, we need about 400,000 liters of water required. All these water, it is coming from our nature. We cannot produce water, we cannot manufacture water, we can only desalinate, we cannot only purify water. In 1940, in India, 1947, how much water an average Indian had, today we have only 20% of that. In 2030, we will be having only 7% of that, what we had in 1947, average Indian. I am talking about the potable water. So, water consumption, not only that, even to produce food products, coffee, chocolate, to manufacture 132 liters of water required to manufacture 1 to 125 milliliters cup of coffee. Right from coffee plants, extraction, everything I'm talking, all together. So similarly, chocolate, beef, cotton, tea, whatever it is, to manufacture food products, we need water. 1 billion people lack access to safe drinking water in 2016. 2.5 billion people lack access to improved sanitation. Recent report, it is not mentioned here, 2-3 weeks before I read. According to World Meteorological Organization, by 2050, 5 billion people will not have access to clean water. That time the population is going to be around 9.2, according to United Nations projections, 9.8 billion people. That means more than 50% of the people will not have access to clean water in 2050. This is the world's water distribution. I'll skip this. If you remember, I can talk to you later. Energy, GDP of a country is directly related to the energy consumption. If a country is consuming more energy, that means they have more industries, more infrastructure development, all these are happening. They are using more energy. Indirectly, they are releasing more carbon dioxide also. America's GDP is more, they are the ones, their per capita carbon emission is more. India's carbon emission is more because the population is more. Otherwise, the per capita carbon emission in India is less when compared to US. So GDP is measured economic growth without considering the finite limit of world resources. Our lifestyle has become such a way that not even a single second goes without the use of energy. More than 80% of the energy comes from the fossil fuels. More than 80% currently we are consuming from the fossil fuel only. We have a lot of opportunities in producing energy from sun, solar energy. The world's current power consumption is 18.3 terawatt. 1 terawatt is 1 into 10 power 12 watts. The incident solar power on the planet is 166 petawatt. 1 petawatt is 1 into 10 power 15 watts. 30% of this reflected back into space and 19% is absorbed by the cloud. So the remaining 85 petawatt is available for use. This 85 petawatt is more than 4,500 times our current world consumption. Therefore, we have a lot of opportunities in producing solar energy. But even if it is solar energy, we need to avoid, wherever possible, we need to avoid use of energy. If it is not possible to avoid, minimize the use of energy. Because even for producing solar energy, we need solar panels, material. That material, where it is coming from? We are already running out of solar panels. We need to come up with alternate materials. Because we are going down, nothing is there. 20 years before, we used to get very good quality minerals in 500 meter or 1 kilometer down. Today we need to go 5 kilometers, 6 kilometers down. Then also we don't get any quality minerals. Going down is not a simple thing. It's an energy intensive process. Lot of energy is required to go down drilling. And that energy always coming from the fossil fuel only, because these mining activities will not happen right in the city. It will happen in the remote locations, and that remote location we cannot distribute renewable energy resources. We need to depend only on diesel generator. Diesel is a fossil fuel, therefore climate change. These are the different kinds of renewable energy resources. Hydrocarbon resources, this is what we are talking about. This is the so-called fossil fuels. Coal, oil, natural gas, LPG gas, petrol, diesel, all these are hydrocarbon resources. They are not only for energy use, most of the chemicals, plastics, they are all manufactured by hydrocarbon resources only. We are completely depending on these only. So when you burn hydrocarbon resources, carbon is there. That carbon, when reacting with oxygen, carbon dioxide is produced. At the same time, energy is required, but carbon dioxide is not required. This is the carbon dioxide we are talking about. That goes to the atmosphere. Many countries in UK is going to phase out petrol diesel by 2040. After 2040, there is no petrol diesel in UK. UAE, Dubai has a clean energy strategy for 2050. I can give you this example. The best university to study petroleum engineering in Australia, if you Google it, you will know Curtin University. But we are going to stop offering this program. We don't want to teach fossil fuel. We don't want to do research. If anybody is doing research in petrol diesel, funding is not given these days. So every country, every university taking responsibility to avoid teaching to hydrocarbon related things. Our campus, for example, Dubai campus is a plastic-free campus, no water bottle. After many years, today I drank water with a water bottle. Do you have an environmental club in the college?
Yes, sir. It's a department.
Material resources, we use different kinds of materials, mild steel, stainless steel, gold, copper, silver, diamond, titanium, tungsten. All these materials, where are they coming from? Table, chair, whatever you see here in this room, everything, shirt, pant, everything, even food also, coming from the mother nature, down only. So that's what I mentioned to you. We used to get very good quality minerals 20 years before. Now we need to go 5 kilometers, 6 kilometers, 10 kilometers down, we don't get it. The global consumption of materials is expected to reach more than 160 billion tons per year by 2060. Approximately 10 billion tons of engineering materials are produced each year. Steel, wood, concrete, this is the civil engineering materials with the largest production rates by mass. Sand and gravel are the most extracted material in the world. Because of the population is increasing, we need to have construction, buildings, industries. Cotton, again population is increasing, textile industries it is required. The consumption of sand is increasing every year. At the same time, the price of sand also is increasing every year. Sand, I am not talking about soil. There is a difference between soil and soil, we will discuss about it. Air is not considered as a resource, it is because it is abundantly available. The problem is the quality of the air pollution because of the greenhouse gas emission. Air is not only used for, it is used for reactant, pneumatic purposes, as a coolant in different places. Now let's talk about soil. This is a very important area where we can focus and we can fix all our problems. If you remove organic content, nutrient content from the soil, then we call that as a sand. If you remove organic content in the soil, then it is called sand. According to United Nations, to call soil a soil, at least 2% organic content should be there. If we go into rainforest, the organic content will be about 70%. In normal agriculture soil, the organic content should be at least 3%. But for example, in India, more than 60% of India's soil, the organic content is 0.5% or less than that. We are on the verge of desertification. Population is increasing. We are converting agricultural land into industries, residential buildings. Soil erosion is happening. Because of sea level rise, we are losing sand. All in all, the land available for food production is reducing. Some studies show that in 2045, we will be producing 40% less food. At the time, population is projected to be 9.2 to 9.3 billion people. When there is a shortage of food on the ground, what will happen? There could be number of civil wars around the planet. That is what the scientists say. Whatever civilization we have built for 500,000 years, everything will break down when there is a food shortage on the ground. At the same time, as I mentioned to you, 5 billion people will not have access to clean water. If food and water is not there, any other problem apart from that, all our small problems will disappear. Our only problem will be that problem. So we should focus on these things. Family problem, money problem, all other personal problems will disappear if food is not there, if water is not there. If soil is not rich, if soil is becoming sand, Then we need to apply more chemical fertilizers. At that time, more nitrous oxide will be emitted to the atmosphere. That nitrous oxide is very dangerous, very powerful, 265 times powerful greenhouse gas. At that time, we will talk about nitrogen footprint, not carbon footprint. Soil is the basis. Soil, 30 to 40 inches of topsoil on an average around the planet is the basis of almost all the life. It is the habitat upon which zillions of lives thrive. Because of that thriving life, everything grows. We get plants, trees, everything. I don't know, here also this culture will be there. I come from agriculture family. When we go to the field, before going, we used to pray and then go into the field. Have you seen this? It is still there. Yeah, because this is the life. This is not there. Nothing is there. We are losing the biodiversity. We heard of dinosaurs going extinct. Now this is the soil extinction. So to keep the biodiversity alive, we need to save our soil. Soil, if it is rich, soil is the largest water source on the planet. If soil is fixed, water is fixed. Soil is the very significant carbon sink. Carbon dioxide is required for food production. Photosynthesis, it takes carbon dioxide and releasing oxygen. So carbon dioxide, instead of going upward, it will go to the downward if the soil is rich. So if soil is fixed, climate change is fixed. If soil is rich, vegetation will happen, food production will happen locally, no need to import, export food. So energy is fixed. If soil is fixed, energy is fixed. If soil is rich, vegetation will happen, trees, plants will grow, air pollution is fixed. If soil is rich, food production will happen locally, we need not import, export food, we can avoid plastics, packaging, we can avoid preservatives, we will get a healthy organic food. So health issues are fixed. So at least 1/3 of the land should go under vegetation, whatever kind, trees, plants, whatever kind. Then we can fix soil. If you don't fix now, there will be nothing to fix after some time. This is the legacy we have received from our previous generations, and we have to pass it on as living soil to our future generations. I don't want to play this again. Yeah, there are a lot of videos available. If you want, later you can see. But this, you can watch this.
Living systems have been around for a few billion years and will be around for many more. In the living
Do you have
world,
time?
there's
Time
no
is there?
landfill.
Shall I take another 10 minutes?
Materials. Food, energy is provided by the sun, things grow, then die, and nutrients return to the soil safely. And it works. Yet as humans, we've adopted a linear approach. We take, we make, and we dispose. A new phone comes out, so we ditch the old one. Our washing machine packs up, so we buy another. Each time we do this, we're eating into a finite supply of resources and often producing toxic waste. It simply can't work long term. So what can? If we accept that the living world's cyclical model works, can we change our way of thinking so that we too operate a circular economy? Let's start with the biological cycle. How can our waste build capital rather than reduce it? By rethinking and redesigning products and components and the packaging they come in, we can create safe and compostable materials that help grow more stuff. As they say in the movies, no resources have been lost in the making of this material. So what about the washing machines, mobile phones, fridges? We know they don't biodegrade. Here, we're talking about another sort of rethink, a way to cycle valuable metals, polymers, and alloys so they maintain their quality and continue to be useful beyond the shelf life of individual products. What if the goods of today became the resources of tomorrow? It makes commercial sense. Instead of the throw away and replace culture we've become used to, we'd adopt a return and renew one, where products and components are designed to be disassembled and regenerated. One solution may be to rethink the way we view ownership. What if we never actually owned our technologies? We simply licensed them from the manufacturers. Now, let's put these two cycles together. Imagine if we could design products to come back to their makers, their technical materials being reused and their biological parts increasing agricultural value. And imagine that these products are made and transported using renewable energy. Here we have a model that builds prosperity long term. And the good news is, there are already companies out there who are beginning to adopt this way of working. But the circular economy isn't about one manufacturer changing one product. It's about all the interconnecting companies that form our infrastructure and economy coming together. It's about energy. It's about rethinking the operating system itself. We have a fantastic opportunity to open new perspectives and new horizons. Instead of remaining trapped in the frustrations of the present, with creativity and innovation, we really can rethink and redesign our future.
Students are here. After your graduation, maybe after 5 years, you will be working on this field. Whatever course you study, whether civil engineering, mechanical engineering, computer science, information technology, you will be studying, you will be looking into the sustainability aspects, particularly circular economy. Because when you are going down, nothing is there. What we have to do, whatever available, we have to rotate it, reuse it, remanufacture, redesign, rethinking, repair and use for some more time. Instead of using your cell phone in 6 months, 10, 1 year, if you use the cell phone for 4 years, 5 years, you are doing something good for the sustainability. It is not that you don't have money, you cannot afford to buy a new one. The nature cannot produce a new one. Whatever products we use, we need to use for maximum time, long time. Even towel, if you are using, use for maximum time, make full use of things and discard them. That's what here it is showing. So, we are approaching a dangerous future. As academics, it is our responsibility to nurture our future generations. How the world will be performing tomorrow is determined by how we nurture our students today. Because they are the very important stakeholders of the future. They are the ones going to live longer on this planet. Positive change begins with an awareness. Awareness empowers people to act. So the first step in creating that awareness should be made by academic institutions. That's what engineering education is very important. So if that awareness is created. Today social media is there. Everybody at least will have 100 contacts in your WhatsApp group, social, Facebook, Instagram. If you make one post, it will reach the 100 people. If that 100 people they share, it will become 10,000. 10,000 become 1 million, 10 billion. We can reach the entire planet in one day. It is not the 20 years before or 30 years before time. So we need to avoid source as well as this is another area where engineers will be working in next 5-10 years. This is industrial symbiosis, regional synergy. It is actually from Western Australia, where our home campus located. I thought of sharing last 2 months before I was there in our home campus. I visited this place. There are 28 industries, but 106 interactions happening. That means what? The waste of one industry is going to the next industry, nearby industry. For example, the waste of wastewater is going to be purified in the next plant. Coal power plant, the waste ash is going to be converted as a concrete in the next nearby industry. Waste of one industry is the raw material for another industry, which is close by. The permissions, approval, licensing is given only if they follow these industrial synergies, then only they will get a place in that location. That means there is no transportation. Everything is within the circle. Every industry is getting their raw material from the nearby industry, not from some other location from the US or China. They get the raw material from nearby industries only. So this is what industrial symbiosis, very iconic place. Now most of the nations like China, America, they follow industrial symbiosis system in a industry park. It is. In industrial ecology. So industries are required. We need to enhance our comfort and conveniences, but at the same time, we need to consider the ecology also. We say marriage between technology and ecology. Now this is the last equation. I will finish with this iPad equation. Very important equation for engineering. Let us say I is the environmental impact, P is the population, A is the affluence, prosperity of people, T is the technology. This is an example only, it is not a realistic number. For example, by 2050, the population is going to be 1.5 times of population in 2000. By 2050, the affluence of people is going to be 10.8 times of the affluence of people in 2000. We always wanted to reduce the impact. We wanted to reduce the environmental impact, climate change impact, ozone depletion impact, acidification impact. All these impacts we wanted to have less. So let us say by 2050 we will have 50% of the impact what we had in 2000. If you want to achieve all these, we need to increase the technology. We need to have innovation. We need to have waste management practices, energy conservation practices, water conservation practices. So if we substitute all these numbers in this iPad equation, I is equal to PAT equation, we get 32.4. That means what? 32.4 times more innovation, more technological improvement should happen by 2050 to achieve all this. I don't know, you studied all this. So thank you for listening. So if you love our future generations, if you love our children and their children, we need to act very quickly. Otherwise, nature will do it in a very cruel way. That is what very important. We cannot fix it yesterday, but we can make it tomorrow better. Let us not be part of pollution. Let us be part of the solution. Let us not create unnecessary torture to our mother nature. Thank you. Wish you all the best. If you have any questions, I would like to thank Mr. Rajesh and family only to listen my talk. They have come all the way from India. Thank you so much. Any questions?
Any questions?
Discussing about the soil and the difference between soil and sand, right?
Yes.
What is the agriculture process in UAE, in Dubai?
UAE is full of desert sand. It is sand only, not soil. There is no agriculture going in UAE. It is now they are converting that soil, that's sand into soil. There are some agriculture going on. That means they are doing something good for the. Already it is sand. Sand is being converted to soil means there is a good one for sustainability. UAE is focusing a lot of sustainability related things. Last year Expo 2020 happened. There is a separate pavilion for sustainability. Sustainability pavilion. Have you visited anybody? Sustainability pavilion Expo 2020. Many nations, more than 200 nations participated. So they create a lot of awareness. And UAE government also is promoting clean energy. By 2050, they have a strategy to have 70% clean energy.
But then to convert from sand to soil, you need a lot of energy, right?
Yeah, no, see, sand to soil, we need to proper management of water, waste.
What about the water?
Again, water is again in UAE. If you are talking about UAE, there is no water sources there. Full of desalination water only. That means there is no other way. But countries like India, we can do much more when compared to them. There are all resources available. We have tree shade, water is available, but we are losing that. Thank you. At least you are asking some question. Think about this. This is the future. My dear students, this is the future. Nothing else. No other problem. When you compare these problems, in front of these problems, no other big problem. This is the problem. This is the most important topic for you. Whatever job you do, wherever you go, whatever study you make, think about, choose these kind of topics. This will help you. You will become the leaders for tomorrow. Energy conservation, water conservation, waste management practices, pollution control technologies. Think about this. Do some projects in these. You will all do final year project. Think about sustainability related projects. We do that only. For example, in our university, engineering, even they do manufacturing project, they should write a chapter on sustainability. Then only thesis will be approved. Otherwise, we don't approve their final year project. Any product, that's why morning also you listened. Sustainable development is an interdisciplinary topic. It is not a one branch, only for civil engineering, only for mechanical engineering, sustainability applicable. No, it is applicable to all of us. Thank you.
We are humbled by the presence of Professor Selvan in the IACE ST 2023. And thank you for sparing the time to share your key message amongst us. Now, I request Dr. Prabhanjan, HOD of CSE JIT, to felicitate Professor Selvan on behalf of Jyoti Institute of Technology. Thank you, sir. We are sure that the audience have found the session to be valuable and informative. And more than informative, it was eye-opening session. And once again, thank you for Professor Selvan for a very good informative session.